Hi, let's work on some applications from Chapter 9, Money Time Value. So far, we covered the theory on calculating future value of one sum and present value of one sum. So let's work on some practical applications now. Well, let's see. We have some applications here that I posted for you. And this one is pretty straightforward because it tells you what to calculate, which is actually not going to be the case for the exam, but we are just learning right now. So in this case, the question is what is the present value of all these amounts for a different number of years and for different interest rates. So present value of one sum is always going to be calculating using Appendix B from the end of your e-textbook. There I showed you in the other video. So you go there and calculate, you take the amount to calculate the present value for, and you go n equals 10 here. Interest rate is 11%, and that's going to be the factor here. The same for the second case and third case. So as you can see here, once you move into higher periods, the amount is going to go down because you discount more periods for the interest rate. And that was present value application. If we want to do an application for the future value, now we are going into the future. We try to add the interest rate. We compound it annually for a number of periods. Here I invest 9,000 compounded for 2 years at a 9% per year, and this is what I end up with using Appendix A now because this is future value, Appendix A. And in 25 years into the future, that's a long time. If you compound it actually here, let's look at this one here first, then you are going to have n equals 25, Appendix A, and then interest rate 14% here. Now I'm gonna come back to this concept later on this problem. For now we take it easy and just do A, B and C to understand how easier applications work. And when we move to different compounding periods, I'm gonna cover the theory on this one first before we do the applications. So now let's think another one. Let's think it through before we actually do the calculations. So we have your uncle offers your choice of 105,000 in 10 years. So you are going to receive this money in 10 years. Or you can receive 47,000 today. Which one should you choose of these two amounts? Well, this amount is today. We know that if I decide I can get this money today, or I can wait 10 years and receive this much more money. Well, before I can make my decision, I would like to know what is present value of this money to be received 10 years from now if I discount it at 9%, and then compare the result to the second choice of receiving this money today. So to calculate that, I'm going to use Appendix B because I want to calculate present value of this amount. And then I go n equals 10, interest rate 9%. And I do the calculations over here. And the result is 47, after I do these calculations here, is 44,310, which is less than what I could get right now. So I'm going to choose this one. The reason your result is so much lower, a lower number, is because you discounted for a higher interest rate. So just remember, the higher the discount rate, the lower the amount, because you take that inflation rate every year out of the future value. Now, another example on the same topic is when we change discount rates. So very similar to the previous problem, but we are going to change the discount rates just to see the difference in the present value when we have different discount rates. So now the amount to be discounted is 105,000, number of years is 12 years. Now if we use 8% discount rate to calculate the present value, So I go appendix B, n equals 12, interest rate, discount rate 8%. That's the factor I multiply with, and I end up with 41,000. This number again, it's lower than what would I receive today, so I'm going to pick the higher amount today. Now, if the discount rate was 8%, but the choice is between 105,000, but you only have 9 years instead of 12 years here, then you do the calculations, and since you discount 3 years less, the difference between 12 and 9, you are going to end up with a higher present value than in previous years, because you don't have those 3 extra years to take out the 8% inflation rate. This is why you are going to end up with a higher amount, and based on these calculations, you are going to choose $105,000 in 5 years rather than 47,000 today in the previous case. Well, then you have some more applications to work on, very similar, take your time. And let's do one more from this topic. Let's see which one is going to be. Let's do this one now. So this person, an investor, invest in a stock that will pay dividends in the future. So when you hold this type of investment, a stock, a common stock, you'll receive $2 per share at the end of the first year. So this is how much you receive at the end of first year. Then you are going to receive 220 at the end of the second year. And then you are going to receive 240 per share at the end of the third year. Okay, so far you have 3 future payments, one at the end of first year, one at the end of second year, and one at the end of third year. And also Jack thinks he is going to receive some more payout at the end of third year again, similar to this one here, but it's the value of the stock, not the dividend. So total we have 4 future payments to be received. Now we are going to consider the discount rate of 11%, and the question is, what is the present value of all these 4 payments? What is the present value? So you see, present value, the wording takes you to appendix B. But we have to calculate the present value for each of the amounts individually because the number of periods is different. So one is going to be received at the end of the first year. So we do present value of $2, n equals 1, interest rate 11%. That's one. The second one, he's going to receive this amount at the end of second year. So you do 220 times from appendix B, n equals 2. This time, interest rate 11%. See how it goes? Then that's the third payment. N equals 3, interest rate 11% from appendix B. And also you have 33, n equals 3, interest rate 11%. For the 2 payments that are going to be received at the end of third year, you can actually add them together and calculate. Either way, you will have the same result. You can do it individually, or you can add only those 2 payments because the year is the same. You see, third for 33, third for 240. And then you add up all those present values and you calculate the total. And this is what we have here. See, appendix B, here is n equals 1, interest rate 11%, n equals 2, n equals 3, n equals 3. And that's the total. So that was some applications from future value and present value of one sum, and you are going to do some on your own.